See this problem. Io, one of the satellites of Jupiter, has an orbital period of 1.769 days and the radius of the orbit is 4.22 into 10 to the power of 8 meters. Show that the mass of the Jupiter is about 1,000th of the Sun. Our motive is, a Jupiter is a planet. It has some moon called as Io, which is revolving around Jupiter with some orbital radius r and within a time period t. It is completing its revolution in a time period t. And apart from that, Jupiter is also revolving around the Sun. We need to find out the Jupiter's mass, which is related with the Sun as mass of the Jupiter is about 1,000th of the Sun. That we need to find out. Mj is equal to ms by 1000. Mass of the Jupiter is 1,000 part of mass of the Sun. This thing we need to prove. That is our motive. Now come to the investigation part. The orbital radius is given, that is r is equal to 4.22 into 10 to the power of 8 meters. And the time period where the moon is revolving around the Jupiter is equal to 1.769 days. So I am converting it to seconds. 1.769 into, in a day we have 24 hours. Each hour has 60 minutes and each minute has 60 seconds. So on a total we will get 1.528 into 10 to the power of 5 seconds. You can calculate at home. And now capital G, which is universal gravitational constant, and the value of that is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. And from the standard table of masses, mass of Sun is equal to 2 into 10 to the power of 30 kg. Now come to the resolving part. It seems to be a little bit confusing, like we need relation between mass of the Sun and mass of the Jupiter, and the values are given for the moon of the Jupiter. How can it be possible? So we have a way. Now consider the first equation of gravitation, that is a gravitational force between two celestial bodies, that is Fz is equal to capital G into mj mm divided by r square. Mj is the mass of the Jupiter, m is the mass of the moon, and r is the orbital radius of that moon around Jupiter, which causes a centripetal force on the moon to revolve around the Jupiter. That centripetal force Fc is equal to mm v square by r, where v is the velocity maintained by that planet around Jupiter. The gravitational force is caused for the centripetal force on the planet, so these two are equal. So I am writing z mj mm by r square is equal to v square by r. Mm gets cancelled and r gets cancelled, so the remaining thing is v square is equal to z mj by r. I want to write a angular velocity component in it, so v is equal to r omega, and omega is the orbital velocity of that moon. So here r omega whole square is equal to z mj by r. I need expression for mass of the Jupiter, so mj is equal to r square into r. Omega can be written as 2 pi by t and its whole square divided by z. And from this I want to write mj is equal to 4 pi square r cube divided by z into t square. This is the expression for the mass of the Jupiter with the known values. So from this expression, if I substitute the known values, mj is equal to 4 into 3.14 whole square into r is 4.22 into 10 to the power of 8 and its whole cube divided by 6.67 into 10 to the power of minus 11 into time period is 1.528 into 10 to the power of 5 whole square. So calculate yourself, and with this I will get 2 into 10 to the power of 27 kg, which is mass of Jupiter. And from the given data, mass of Sun is equal to 2 into 10 to the power of 30 kg. So if you take mj by ms is equal to 2 into 10 to the power of 27 divided by 2 into 10 to the power of 30. 2 gets cancelled, and here you will get 1 by 1000. And it is clear that mj is equal to ms by 1000. That is, mass of Jupiter is 1000th of mass of Sun.